Just finish off the notes, page 100, page 101. So we're doing that same process that we had before. So basically the question asked us to find increasing and decreasing and our relative extrema, but it could have asked us any of these things: increasing, decreasing, max, min, critical point. Our first step, set f prime to 0. We're going to solve. We're going to make our number line analysis, plug in numbers in between, figure out if they're positive or negative, and then use that analysis to write our answers. So first step, we're going to write f prime of x, and that's going to be 15x to the fourth minus 15x squared. We're going to set this equal to 0. We can factor out a 15x squared here, and that gives us x squared minus 1 equals to 0. Now basically what we're doing is we're taking this part and this part. Anytime we're multiplying, we take each piece, we set that equal to 0. So we can say 15x squared equals to 0, and then we can have x squared minus 1 equals to 0. Okay, this one we divide by 15, you get x squared equals 0, square root both sides, and you get x equals 0. There's no plus or minus here, it's just 0. On this one, two choices. We can go x plus 1, x minus 1 equals 0, and that'll give us x equals plus or minus 1. Or you can add the 1 to both sides, x squared equals 1, and you can square root both sides. Either way, you should get x equals plus or minus 1. So by the way, these are our three critical points. Okay. Now we're going to make a number line analysis. Make sure you always label that number line f prime. I'm going to throw negative infinity over here, positive infinity over there. Negative 1 is the smallest, 0 is next, and positive 1 is the biggest. Okay, so now we're going to just kind of think, what numbers could we plug in? And we want to be plugging in here where it's most factored. Okay, you could plug in up here to f prime, but I like to plug in where we had it most factored. So we're going to plug in, basically a number that's in between negative infinity and negative 1 in there. So a number in between negative infinity and negative 1, I'm going to plug in, like, say, negative 5, negative 2, negative 10, anything like that. So I like to just kind of, write up above it. So writing in right here, right? And I like to just kind of think, is it positive or negative? So if I plugged in negative 5, negative 5 squared is positive. 15 times a positive number is going to stay positive. Then negative 5 squared is positive 25. 25 minus 1 is positive. So this is a positive number times a positive number. That's going to give me a positive number. I could care less what it is. I just am checking, is it positive or is it negative? That's why it's a number line analysis. Next, we're going to plug in a number in between these two. So say negative 0.5, right? So 15 times negative 0.5 squared, right? Negative, or negative 1/2, right? Negative 1/2 squared is positive 1/4. So 15 times positive 1/4 is positive. Let's erase this and just kind of redo it. So we're going to have positive here. Then, negative 1/2 squared is 1/4. 1/4 minus 1, that's going to be a negative number. So negative. So this is a positive times a negative. A positive times a negative gives us a negative. Now we're going to do it again for a number in between 0 and 1. So let's say positive 1/4. Okay, positive 1/4, we're actually going to get the exact same result. Positive 1/4 squared is positive times 15 is positive. Positive 1/2. 1/2 squared is 1/4. Positive 1/2 squared is 1/4. 1/4 minus 1 is a negative. So again, we're going to get a positive times a negative. So this is going to give us a negative. And then let's plug in a number between 1 and infinity. You do 2, 10, 5, whatever. I'm going to do 2, it's easy. So 2 squared times 15, that's a positive number. 2 squared is 4. 4 minus 1 is a positive number. Positive times a positive gives us a positive. So this is going to be increasing, then it's going to be decreasing, and then it's going to decrease some more. What I like to do here is I like to kind of decrease it, put a little point, decrease it like at a different rate, and increase. So, this is still a critical point, but it decreased and continued to decrease, so it's not going to be a maximum or a min. So, this section here, my graph is increasing and increasing. These two sections, my graph is decreasing and decreasing. And then right here, we're going to have a relative max. And right here, we're going to have a relative min. And at 0, this would be a critical point, but neither a max or a min. Okay, you don't need to write all of that down for notes. You can if you want to, but when you're doing a problem, you don't need to. What you do need to do is you need to answer the questions that were asked. So they asked, where is f of x increasing? So f of x is increasing for, we're going to look at our number line analysis, right? Negative infinity to negative 1 and 1 to infinity, those pink highlighted sections. And then remember I said we're going to just use brackets for increasing and decreasing anytime we get a non-infinity number. And we want a because, so because f prime of x is greater than 0 for those intervals. You can either say f prime of x is greater than 0, or you can say because f prime of x is positive. You could write, f prime of x positive. Next, where is f of x decreasing? So f of x is decreasing for, and then that's going to be, this section. So f of x is decreasing. You can combine it because they're next to each other. So you can say for negative 1 to positive 1 because, put the because down here, f prime of x is less than 0. Now, you could say for that interval, if you want to be super precise, technically, f prime of x is decreasing for negative 1 to 0, union 0 to 1. And that's just because, we'd use parentheses and split it up because at these 3 points, f prime of x actually is not less than 0, it's actually 0. Okay. So the most precise answer would basically be to say something like this. F of x is decreasing for negative 1 to 1 with brackets because f prime of x is less than 0 for negative 1 to 0, union 0 to 1 with parentheses. Now, if you said it, the other way just for that interval or for that, you'd be fine. Okay. Next up, let's check our relative maximums. So f of x has a relative max at x equals negative 1, right? It's up here, this guy here, right at the top of that, kind of number line analysis. And it's why? Because what did we do? We changed, f prime changed from positive to negative. So because f prime of x changes from positive to negative at x equals 1. You'd also say at that point. Now, one thing I want to kind of really make sure we talk about. This is very, very important. You need to be specific. Okay, hopefully you're watching this video, you're paying attention. You need to be specific here. Please never, ever say because the graph, it's a big no-no, I will mark that wrong. Which graph? And please never, ever say because it. One of you is going to say this. You're going to write this down. I'm going to make fun of you. I'm going to call you out. I'm going to tell the whole class that you did it. Please never, ever say because it. Okay, that's a big no-no. We have no idea what it means. You need to be specific and say because f prime of x changes. All right, and then our last one. All right, and feel free as well. If I ever write it, feel free to call me out on that. All right, is where do we have a minimum? That would be at x equals 1, right? X equals 0 is neither. So f of x has a relative minimum at x equals positive 1 because f prime of x, again, we're being specific, we're not saying it, changes from negative to positive at that point. Now, all the notes asked us to do was this, but on your first quiz that we're going to take, I'm going to actually ask you a question like this. I'm going to say classify, or sorry, first I'm going to say identify each critical point. And then I'm going to say classify each as a relative max, min, or neither. And so this is kind of a two-part thing, and it's going to say justify. So the first part is to identify the critical points. You want to justify this. So you want to say a sentence like this. F of x has a critical point at x equals negative 1. Don't forget 0 and 1 because f prime of x equals 0 at those points. You want to say that, right? Then the second part is going to be the relative maximum. Okay, what we just said here is perfect. So you're just going to kind of copy this down. Okay. All right, then we want to say, where do we have a relative minimum? So same idea, we can just kind of copy this down. Or we're classifying each. So we're going to do that. But this actually only classified -1 and +1. What about 0? Well, it said to classify each as a maximum, minimum, or neither. So we want to also classify 0 and say, okay, like x equals 0 is neither a relative max or min because f prime of x does not change signs, right? We don't change signs there. Don't say, f prime is negative or something like that. Just say it doesn't change signs. All right, and then this one, it's the same idea, but we're just going to look at how might this look with trigonometry. So everything starts the same way. We're going to take f prime. We're going to set it equal to 0. F prime here is 1 plus the derivative sine we should have memorized as cosine. And then that equals to 0. Subtract the 1. Divide by 2. You can do this in one step, by the way. You can jump straight from here to here if you want. And then the best way, I like to do this is by doing inverse cosine. Okay. And so we're asking, where does theta, which theta gives a value of -1/2 for cosine? So, if you have your table, sine, cosine, tangent, you're looking here, right? You have 0, pi over 6. If you forget, just kind of draw this out, pi over 4, pi over 3, pi over 2. And you can draw it all the way out, right? 0, 1/2, rad 2 over 2, rad 3 over 2, 1, go backwards, 0, 1/2, rad 2 over 2, rad 3 over 2, and 1. I would recommend always doing this the very first time that or the very first thing you do when you get a test, and then you just have it for the whole test. And then all students take calculus. So we want, where does cosine give us 1/2? That's at pi over 3. But this is the negative slot, so it's going to be, cosine is positive here, and cosine is positive here, right? The all on the C, and negative here and negative here. So we want these two. So it's going to be at 2 pi over 3, 1 less than the denominator, and 4 pi over 3, 1 greater than the denominator. Now, this is also important. When we make that number line analysis, we are not going to do arrows anymore. We're going to do brackets. And the reason we're doing brackets is we're just going from 0 to 2 pi. So I'm going to put 0 here, 2 pi there. We're going to close that off. Still label it as f prime. That's super important to label it. And we're going to put 2 pi over 3 here and 4 pi over 3 here. So we're going to plug in. And we want to plug in where we had it, the most factored, but still as equal to 0. So we want to plug in there, okay, because it's still equal to 0. That's going to give us the sign. So we want to pick a number here, okay. Well, what I like to do is kind of look, okay, 2 pi over 3 is in this quadrant here. So between 0 and 2 pi over 3, to me, the easiest to always plug in would just be this point here, right? 0, 1. And so cosine of 0, I'm plugging in, is 0. Sorry, not cosine of 0, cosine of pi over 2. We're going to plug in pi over 2. Okay. So if I plug in pi over 2, I get 1 plus 2 times cosine of pi over 2 is 0. 1 plus 0 is a positive value. So this is going to be a positive value. Now I'm going to give you a shortcut. 99% of times, it just goes negative, positive, whenever we have trig. But let's check it to make sure that happens. So we positive. Now let's plug in a number here. So in between 2 pi over 3 is this quadrant. 4 pi over 3 is down here. The easiest thing to plug in would be pi, -1, 0. So when I plug in pi, cosine is -1. So this is going to be 1 plus 2 times -1. That's 1 minus 2, which is a negative sign. So it's going to be negative. And finally, we're going to plug in something between 4 pi over 3, which is this quadrant, and then 2 pi, which is over here. So something in between here. So the easiest thing for me to plug in would be 3 pi over 2, which is 0 and negative 1. So again, we're plugging in 0. Right? We did this before. That's 1 plus 2 times 0. 1 plus 0 is positive. Okay. So it worked out the way I said it would. We're increasing, we're decreasing, we're increasing. Okay, now we'll just do this as quickly as we can, but we got to write them out. F of x increases for 0 to 2 pi over 3. We're no longer going from infinity, negative infinity to infinity, because they gave us, those endpoints. 4 pi over 3 to 2 pi. Because f prime of x is positive, or you could say greater than 0, for those intervals. Same idea now with f of x decreasing. F of x is decreasing for 2 pi over 3 to 4 pi over 3, because f prime of x is less than 0. For that interval, it's singular. Then where do we have a relative maximum? Up here at top, relative minimum down there. So f of x has a relative max at x equals 2 pi over 3, because what happens? F prime of x changes from positive to negative, and then we always need the what and the where. At x equals 2 pi over 3, or you could say at that point. All right, and then finally our last one, f of x has a relative minimum at x equals 4 pi over 3. Same idea, because f prime of x changes from negative to positive, right, the opposite way. At that point, negative to positive. And I'll just show it a different way. You could just say at that point is fine. Okay. So hopefully that helps us. Homework is very, very similar. Number 1, we're taking the derivative, setting equal to 0. You will have to factor. Number 2, same idea. Number 3, first FOIL. So first expand and FOIL this out. Then take the derivative, set it to 0, same idea. There was no trig there, so that's kind of nice. Then this guy's the same idea, but with our derivative. And again, this is the graph of f prime already. So we're looking for the same concept, whereas f of x increasing, whereas f of x decreasing. We want those same justifications. We're going to use this table. All right, whereas f of x increasing, we're going to look where f prime of x was greater than 0. And the page you can look at is just look at page 98. Make sure you understand page 98, and those bottom 2 questions will be the exact same as that.